Welcome back to the Deep Dive. Today we're getting into something pretty fundamental, changing heavy industry. Specifically, how artificial intelligence is, well, really starting to run the show in the global mining sector. We're not just talking basic automation here. We're diving deep using our source material into this idea of self-aware mines. Our goal is to unpack what that actually means and how it's rewriting the rules, operations, strategy, even the economics of it all. Think less dusty worksite, more autonomous brains moving mountains.
Exactly. And that self-aware mine concept, it's crucial. It's really the step beyond just having a robot follow a script.
Right.
It's about creating a whole digital ecosystem that can sense, adapt, and optimize itself, in real time. And a big part of that is these partnerships forming between the AI developers and the big equipment manufacturers, the OEMs.
The OEM AI connection.
The machine itself is now part of this live decision-making network.
So that partnership is kind of the bedrock for this shift. And it's just to give everyone a sense of the scale here. I mean, the amount of work already being done by these autonomous fleets is kind of mind-blowing. This isn't science fiction anymore.
No, absolutely not. It's core operations for many, and the numbers, well, they really tell the story.
Okay, let's start there then with the scale, because some of the figures in the material are just staggering. You look at Komatsu, for instance. They report having over 750 autonomous trucks out there operating right now, globally.
750, that's a lot of trucks.
And get this, collectively, those fleets have hauled over 10 billion tons of material.
10 billion, it's almost impossible to really grasp that number.
Right, just pause on that. 10 billion tons of earth moved, mostly without a human driver in sight.
And it's important to note, it's not just one company dominating this. Komatsu's a giant, yes, but you've got major players like Caterpillar throwing huge resources at this too.
With their MineStar system, right?
Exactly, MineStar. Think of it like the operating system for the intelligent mine. It manages everything, tracking assets, allocating resources precisely, running optimization software. It shows the whole industry is moving towards these really comprehensive end-to-end digital setups.
I see. So it's not just about big trucks anymore. It's this massive interconnected software layer controlling them. And that changes what automation is, doesn't it?
It really does.
It feels like it moves from just, repetitive autonomy to something genuinely predictive and adaptive. The machines aren't just following lines on a map.
That's the critical leap. They're calculating efficiency against hundreds of variables instantly. Operations aren't running on fixed schedules set by a supervisor looking at yesterday's data anymore. They run based on this constant stream of microscopic data feedback, and that's why you see it spreading across everything, not just the big haulage fleets, but also specialized gear like drilling systems.
So the drills are adjusting on the fly.
Precisely. They're making real-time adjustments based on the geology they encounter, like the second they hit it.
But hang on, if the OEMs, the equipment makers, are driving this digital ecosystem, does that create a risk of getting locked in? If you buy into MineStar, are you stuck with Caterpillar's AI only? Or can these systems talk to each other? That sounds like a big deal for capital planning.
It's a huge strategic point, because now procurement isn't just buying hardware, it's more like subscribing to a data service.
Right.
So there's this tension. On one hand, an OEM's AI might optimize its own equipment best, that's proprietary efficiency. But mines often use equipment from multiple vendors.
So they need things to work together.
Ideally, yes. Standardization is the long-term aim. The source material suggests that right now, that proprietary data integration, it's still a major competitive edge for the big OEMs. It can effectively lock operators in if they want peak performance.
Okay, that makes sense. So the vehicles are the endpoints doing the work. What's the underlying tech, the actual mechanism that makes this self-awareness possible? It must be some kind of data infrastructure that lets the mine sense things first.
Exactly right. Data effectively becomes the new infrastructure of the mine. To get self-aware, the physical environment has to be digitized completely. Through this explosion of IoT, Internet of Things. They're embedded everywhere. Vehicles, stationary monitors watching rock faces, conveyor belts, even mapping the landscape itself.
Wow.
And they capture everything: vibration, GPS location, fuel burn, material density, slope stability. You name it.
That sounds like an absolute flood of data just constantly pouring in. How on earth do you process that fast enough for real-time changes?
Yeah.
You can't be sending it all up to the cloud and waiting for an answer, surely.
You can't, no. And that's where the architecture gets really smart. It uses both. You have the big cloud platforms for the heavy lifting, long-term analysis, storage, training the AI models. But crucially, it relies on edge computing.
Edge computing, processing data right there at the source.
Exactly. Right there at the mine site, sometimes even on the vehicle itself.
Okay, give us a concrete example. How does edge computing enable that split-second decision that makes it self-aware?
Okay, picture a big autonomous haul truck in an open pit. Instead of waiting for a daily checkup, its onboard edge computer is constantly processing data from its internal sensors.
Mm-hmm.
Let's say it detects a tiny, sudden rise, maybe 2 degrees Celsius, in a rear axle bearing temperature.
Okay.
It doesn't just see that number in isolation. It instantly cross-references it with other real-time data from sensors nearby. Maybe this bit of road has a steeper grade because of recent digging, and maybe the ambient air temp is high right now.
Got it. Connecting the dots.
Connecting the dots instantly. The system determines that under these specific conditions, the current maximum speed setting for that axle load isn't sustainable. It doesn't need a human supervisor miles away to get an alert and make a call.
It just acts.
It adjusts the truck's maximum speed and maybe its transmission mapping immediately to prevent a potential failure. That's self-optimization, driven by data processed right there on the edge.
Wow. Okay, that infrastructure fundamentally changes how you manage risk. You're moving from fixing things after they break to predicting and preventing issues. Hugely efficient.
And that ultimately is the mechanism that creates value for you, the listener, whether you're looking at operations or the financials. Understanding this data flow, the role of the edge, that's key to grasping the scale of this transformation.
So, assuming the tech works as planned, what does this mean for the bottom line for the CFO? This takes us into the tangible impacts: economics, safety, global competition.
Well, the economic impact is profound. You see immediate results in 2 main ways. First, significantly lower operating costs per ton. That comes from just running more efficiently, optimizing fuel, consistent cycles.
Makes sense.
And second, dramatically higher overall productivity. Simply because machines don't need breaks, they don't get tired, they can run optimized routes 24/7, but there's a big consequence for the workforce.
Yeah, the human element.
The needs are changing rapidly and fundamentally.
You're shifting from needing lots of skilled operators driving the machines to needing highly specialized IT techs, data scientists, remote fleet managers overseeing the algorithms.
Precisely. It demands a completely different skill set. Often, it means a smaller workforce overall, but one that's much more highly skilled. And that, changes the economic fabric of regions historically built around traditional mining jobs.
Beyond the pure economics, though, the source material really stressed the huge gains in safety and ESG, environmental, social governance. That seems like a massive benefit.
It's arguably the most compelling non-financial plus. AI drastically cuts down human exposure to mining's inherent dangers.
Like working deep underground or unstable ground.
Exactly. Or dealing with potentially hazardous materials. The machines take on that physical risk.
And the ESG part. How does AI help there?
The monitoring capability is just unparalleled. AI systems can continuously track environmental metrics, water usage, emissions, whether you're complying with specific regulations with a level of detail manual checks could never achieve.
So better accountability.
Much better accountability, more transparency for sustainability reporting too.
Now, this tech isn't just sitting still. The sources paint it as almost a global arms race for competitive advantage. They mention Australia, Canada, Chile specifically as being way ahead in AI adoption. Why them?
Well, those countries often tick several boxes. They have huge, important resource deposits, stable places to invest, but they also tend to have high labor costs and very strict safety and environmental rules.
So the pressure is higher.
For them, AI isn't just nice to have. It's almost the only way to stay cost competitive globally while meeting those world-class safety and environmental standards. And their commitment, it forces everyone else's hand.
How so?
It basically resets the baseline. Any major new mining project anywhere in the world now has to factor in the cost and capability of this digital transformation just to be in the game. It changes global capital planning.
Which brings us nicely to the bigger picture, the strategic and policy side of things. The Skillings analysis we looked at basically said this level of AI adoption isn't optional anymore. It's becoming essential for survival in the industry.
But necessity creates its own problems. Big ones. First off, regulators are struggling to keep up. Think about applying safety rules written for human drivers to a fleet of autonomous trucks making their own decisions, maybe even crossing state or national borders. How do you regulate that? Who's accountable if an autonomous system fails? Governments are scrambling.
And there's the social risk you touched on earlier, the digital divide.
Yes, this is critical. The giant multinational mining companies, the ones operating in places like Australia or Canada, they can afford the massive multi-million-dollar investment to digitize a whole mine.
But the smaller guys can't.
Smaller operators, maybe in developing economies, they often just don't have that kind of capital.
And the danger there is.
The danger is existential for them. If you can't afford the tech, you can't match the cost per ton that the AI-enabled mines achieve. You also struggle to meet those increasingly tough global standards for safety and ESG.
So they get squeezed out.
There's a real risk of marginalizing smaller players, potentially concentrating control over vital global resources into the hands of just a few very highly capitalized companies. It really demands some critical thinking about policy solutions, maybe shared infrastructure initiatives, or regulatory support to make sure this tech wave doesn't leave so many behind.
Yeah. It's been fascinating mapping this out, how heavy industry is being fundamentally redefined by software, by data. These massive industrial sites are turning into, well, hyper-optimized autonomous data centers buried underground.
It's quite the transformation. So just to recap the key takeaways for everyone listening, we saw the incredible scale of automation already happening. Komatsu's 750 trucks, billions of tons moved, driven by those OEM AI partnerships.
Right. We clarified that data is the new core infrastructure, enabled by IoT sensors and, crucially, edge computing, which allows that self-aware adaptability. This brings huge benefits to lower costs, much better safety, stronger ESG performance. But finally, we stressed the global race, seen in places like Australia and Chile, and the urgent policy questions around that digital divide and how regulations can possibly keep pace.
It really does change everything we thought we knew about getting resources out of the ground. So here's a final thought for you, the listener, to mull over.
Okay.
Given how effective AI is proving to be at reducing human exposure to really serious hazards in mining, how might these shifting workforce needs start to accelerate changes in policy, specifically around things like minimum staffing levels or maybe training standards, especially in regions with historically strong mining unions?
That's a powerful question.
If the safest crew turns out to be a remote crew, how fast will labor laws and regulations adapt to, potentially, minimize the number of actual humans physically required on site? A really potent thought, connecting the tech directly to socioeconomic policy. Definitely something for you to keep exploring as you watch AI's impact spread across all heavy industries. Thanks for joining us for this deep dive.